Fast.
I just started this second, so everything you say from now on is being recorded, so think twice.
Okay.
Yeah. So do you want to say a few words, or do you want me to just kick it off?
Sure, I can just give a quick introduction for the folks on the call. So I had met with Moshe, I think a year or two ago, and really good conversations. And then he was kind enough to do a couple of demos for me. And I think this tool is brilliant. As with any automation, I would be cognizant of the fact to really put it in context and see if you need to do certain types of automation or not. But if you need to do visual regression, I think this product, I was really fascinated with it if it fits into your context well. And thankfully, Moshe agreed to do another demo. Unfortunately, he's not well. So Adam stepped in last minute. So thank you so much, Adam, for doing this for us again. And I'm hoping this increases awareness of different opportunities of different types of automation that can be done and how Applitools fits into the picture.
Okay. Okay.
So the floor is yours.
Okay, thanks, Anand. Thank you very much. So hi, everyone. My name is Adam Karmi. I'm a co-founder and the VP of R&D of Applitools. And we'll start with a brief introduction to visual testing and Applitools, and then we'll just, the rest of it will just be a demo of the product. And if you have any questions, just feel free to stop me and ask. So we have about, let me see, 55 minutes of time to do this, so we have more than enough. So feel free to stop me with any questions you may have. Okay, so let's start with what is visual testing. So basically, it's a quality assurance activity that is aimed to verify that the graphical user interface appears correctly to users. Now, this goes beyond the traditional functional testing that you used to do with tools like Selenium and QTP, where you actually test the functionality of the application through the UI. What we're focusing on here is making sure that the UI itself looks good to the end user, making sure that each UI element appears at the right color, shape, position, and size, that it does not overlap or hide any other UI elements. Now, this type of testing has become increasingly difficult to perform in recent years just because of the huge variety of web browsers, devices, screen resolutions, and operating systems that application has to run on today. So here's an example of a visual bug that we found in a Microsoft Azure management portal. You can see here how the graph exceeds the expected bounds of the page. And here's another one from the Financial Times. You can see that the article title overflowed on top of the article body. And in this case, the top bar of this website just disconnected and appears, does not appear where it's supposed to be on IE8, while on IE11 it does appear where it's supposed to look, and this is how it's supposed to look. So I'm sure that you've all seen this type of bugs many times and you understand their importance. They are very embarrassing and can hurt the brand of the company. But beyond that, they can actually cripple the functionality of the application and cost a lot of money. So just think of an e-commerce site where the product catalog is corrupted, or if you cannot find the checkout or purchase button. That's like a huge functionality breaker for such an application. So why should we automate this type of tests? So there are many reasons, but the most important one that it's practically impossible to cover the test metrics because it's so big. Think of all the different web browsers, devices, operating system, and screen resolutions. We all know that if a website looks good on Chrome, doesn't mean that it looks good on IE8. And we know that if an app looks good on a widescreen, doesn't mean that it looks good on a smartphone. So basically, we have to test the way our application looks and behaves on all these different execution environments. If the application or site is also responsive, and most modern applications are, then we also need to take that into account and check all the different layout modes in all these different execution environments. And if we're also localizing our site or application, then we need to factor in the different fonts, resources, images, and content because they affect the way our application is displayed. And as you can see, it's just such a huge test matrix that it's quite impossible to thoroughly test manually in a repeatable and reliable manner. What makes things even worse is the trend in recent years that continues to shorten the release cycles. So the recent hype, which is continuous deployment, dictates that whenever a developer commits a line of code, it triggers an automated process that results with that piece of code being pushed to production. And companies that are doing continuous deployment actually release code to production several times a day. And with such short release cycles, it's hardly possible to do any type of manual testing, let alone making sure that the application looks good on so many execution environments. When we're talking about native and hybrid mobile apps, it's get even worse because it's much harder to roll back changes. So if you have a bug, you're stuck with it in production for some time. You cannot push daily to the App Store, and even if you manage to work around that, frequent updates take battery and data and eventually reflect badly on your application and upset your customers. And in general, there's a much higher quality bar for mobile apps just because mobile users are much less tolerant to UI and UX bugs. And also, it's no secret that that doing this type of testing manually is quite error prone. I mean, humans are not very good at spotting tiny visual differences, but when you let a tester look at the same screens over and over and over again for the 1,000th time, he ends up missing out on very big and embarrassing differences, and those tend to end up in production eventually, and we don't want that. So a few words about Applitools. So Applitools is the only commercial solution today for performing large-scale automated visual testing. It allows you to automatically validate the content, data, layout, and appearance of all the UI elements on your screens with a single validation command. It does that for all your screens, for all the UI elements in them, and in all the different execution environments that should be supported. There are several features in the product that allow you to easily maintain those visual tests across all these different screen resolutions, operating systems, and devices and browsers, as I will show you in the demo soon. It's also important to highlight that although Applitools Eyes is mainly the main differentiator is that it allows you to validate automatically all the visual aspects of the application, it's also a very, very powerful tool. In fact, it's a game changer when it comes to doing functional validation as well. Every piece of functionality which output is available in the UI can be tested using this tool. Just to give you like a naive example, if you have a calculator and you enter 1 + 1 and it comes out as a 3, then 3 does not look like a 2. The tool will catch that, but still it did catch a visual difference, but it indicates a functional defect. So Applitools has been recently named a cool vendor by both Gartner and Forrester in their application development and functional test automation tools report this year. We have more than 6,000 users today, with customers ranging from small startups to very large companies and enterprises in all the major verticals. And that's it about the company. Let's talk about the tool, how it works. I mean, any questions to this point about Applitools, about what visual testing, why we need it, or can we just go on?
I think we can proceed, Adam. So the folks who are joined and who would be seeing this are fairly very technical, for sure.
Excellent, excellent.
So I think we are getting to the crux of it now, and that should be really interesting.
Excellent. So how does it work? So the tool works with a very simple workflow that has 4 steps. In the first step, you drive the application on the test and take screenshots, and you can use practically any test automation tool that you want, that you're currently using. starting with Selenium and Appium and QTP and LeanFT and Mobile Center and whatever tool you want, Coded UI, to just drive the application on the test and get those screenshots. In the second step, the tool takes those screenshots and compares them with baseline images. Baseline images define the expected appearance of the application. These could be images that were taken in the past and approved previously by a human tester that saw them and approved them, or they could be screenshots that were taken simultaneously with the screenshots that are to be validated only from a trusted execution environment. So for example, one very common way to do visual testing is to validate your staging deployment using your production deployment just before releasing the staging deployment to production. So the way you do it is that you run a test simultaneously on both environments. You take screenshots from both environments, use the screenshots taken from the production environment as a baseline to make sure that there aren't any unexpected changes in your staging environment. In the third step, the tool takes all these screenshots, the baselines, and the differences, and it generates a report that clearly highlights everything that happened and any differences that were found. And in the fourth step, a tester has to look at the report, assuming there were differences, and decide for each difference whether it's a bug, in which case he opens a bug, or if it's a valid change to the application, then he just approves the new screenshots to be used as a baseline for subsequent runs. And of course, the first time you run a test, it doesn't have a baseline yet, so the screenshots that are taken on that test are automatically approved as a baseline, and from the second test onwards, you have something to compare against. So that's the main workflow. And let's move on to the application and see how it works. So what you're seeing right now is a side-by-side view of a test results of running a visual test against my Gmail account. On the left-hand side, you can see the baseline image, and on the right-hand side, you can see the new image that we're validating. The differences are highlighted in pink, and we also have this radar button here that when we click it, it highlights those differences so we don't miss out the small ones. Let's take a closer look at the differences that we found in this specific test. So first of all, you can see that we have a typo in the More button. You can see that the Google logo has moved. And you can see that the search button changed color from blue to green. Now, there are a few important things to notice at this point. So first of all, you can see that the tool captured visual differences that you wouldn't expect traditional test automation tools to find. You would usually rely on manual tester to find this type of bugs. The second thing you should notice is that this single validation point that required you to write a single line of code in your test actually captured and validated an entire screen that consists of hundreds of UI elements. And it actually saved you the trouble of writing hundreds of lines of equivalent test code. It saved you the time to write them and to maintain them moving forward. So we didn't have to identify those different elements and prepare expected data for them and maintain their locators and identifiers as the application progressed. It just like a human would look at the screen and see, a human tester would be able to tell that it looks good, it works the same way. The third thing to notice is that, as I mentioned before, beyond the visual differences that would be found, a lot of the functionality that's lying behind this application is also being tested here. So for example, the list of folders that is available to me, if something would break in the database or in the query itself, the list would be different. And that would be caught as a visual difference that indicates a functional defect. The same goes with the sorting order of this table. If something would break and the emails would appear in a different sorting order, then that would also be captured. When you are comparing images with Applitools Eyes, you have several image processing algorithms to choose from. And this is actually what differentiates Applitools Eyes from everything else in the industry, because we have the most powerful image matching engine out there today. So the first matching algorithm that you can use is strict. Strict matching is, as the name implies, it's a very strict matching algorithm. It can find minute changes on very, very large screens. So it could find that a plus symbol changed to a minus symbol or a dot changed to a period. But on the other hand, it can completely ignore huge differences that are invisible to the human eye. And there are many such differences that occur all the time, and you need a very, very powerful image processing algorithms to be able to detect and ignore them. So just to name a few, for example, on a web page, it's very common to have tables, and when you have a table, it's very common, even on the same browser, that sometimes one of the columns would render to be 1 pixel wider. When that happens, the rest of the columns are shifted 1 pixel to the right, and you have a huge pixel-wise difference. But as humans, we cannot see that, and we don't care about this change. It's a natural behavior for the browser. And so we don't want our tests to fail in these situations. And this is exactly what Strict knows to do very well. So there are other differences, many differences that occur when you're rendering graphics on different computers, which usually happens if you have more than one tester and if you're working in a lab, right, running your test on a lab with many machines. So just to show you a bit of the capabilities that Applitools Eyes have under the hood, you can see here this image with this pink rectangle being magnified in the center. And if you take a look at the pixel below this white border and the way that it renders on two different machines, you can see how different the pixels are here below the border. So this is due to an effect called anti-aliasing. Basically, you have two machines with two different graphics cards and you get this rendering difference. So although it's almost invisible when it's magnified, and you can definitely not see it on the normal scale, but still this is something that the computer sees, and you need to have advanced algorithms to be able to detect this change and understand that a human cannot see it and just ignore it. So here's another change that has to do with the pixel brightness. This could happen, for instance, if you just connect a screen with different capabilities to the same machine. Here you can see an example where an element is moving on screen, but it's not moving individually, but each letter is positioned on its own. And you can see here the A and the O that actually change the pixel, the way that pixels are rendered, and it's as if the letters are moving. And then again, these are not just like 2 or 3 pixels that are different, and the algorithm is capable of identifying that this is something that a human cannot see. And the last example has to do with image scaling. Whenever you have an image on your web page or mobile app, and the source for that image element is not exactly of the same size, then the graphics card has to scale the image to fit at the boundaries that you've specified. And if you have two different graphics cards, and if they are configured differently, then you just end up with different pixels because the algorithms are different. And so if you look at this image here and this pink rectangle magnified, and you see the pixels, the way that they are rendered on two different environments, you can see that the pixels are very different, although to us as humans, we cannot see that. And again, the algorithm is smart enough to identify and ignore the situations. When we're dealing with strict matching, it's very important to be able to cope with dynamic data. So for instance, when I'm running my test against my inbox, every time I run it, I have a different ad. So it's very easy to let the image matching engine know that it needs to ignore this area so it won't fail our test, just by drawing an ignore region on top of it. So you don't have to change code. You can have your manual tester do this type of maintenance, and it's a very effective way to just ignore dynamic data. Similarly, if you have this Google logo that is moving, it could be moving because it's animated, or perhaps it's tied to another element that changes size. So you can just mark it with a floating region. And when you do that, the tool automatically found the area in which the logo is moving, and you can further adjust it. And the way that it works is that as long as the Google logo appears within these bounds and it does not change, then this difference will not be flagged. But if the Google logo will change in any way, or it will appear outside these bounds anywhere else on the page, then the change will be flagged and it will fail your test. The next match level which is supported is content. Content matching is very similar to strict, only it ignores style and color differences. So in our example, you still see the typo and the Google logo moving, but the fact that we have a different color here on the search button is no longer flagged. The next match level that I'll focus on is layout, and it's a very powerful match level because it allows us to test very dynamic pages and also do cross-browser and cross-device visual testing. So in layout mode, we only care for structural and layout differences between the baseline image and the image that we validate. And in this case, the only difference that breaks this layout is the Google logo moving. So the fact that we have a typo or a color change doesn't matter anymore. And in fact, we can also remove the ignore region here on the ad, because although there's a different ad, the layout is still consistent. Okay, so let's take a look at another example of how layout matching can be used to validate the correctness of very dynamic pages. So in this case, we are looking at the Yahoo homepage. Yahoo has the portal is very dynamic. And in this case, the baseline and the image that we validate were taken at a 24-hour difference. So as you would expect, the images are different and the articles are different, but still, as far as layout is concerned, there are no differences and the test has passed. Okay? If I would change this back to strict, then you can see that all the dynamic parts will be highlighted in pink, and all the static ones are still left as unchanged. But if I would change this to exact pixel matching, you can see that everything on this page is highlighted as a difference, because even the static ones that we cannot see that have changed did actually change at the pixel level, only strict was smart enough to ignore that. Another use case for layout is doing cross-browser testing. And in this case, you can see this is a paycheck site. The baseline was taken from Chrome, and the image that we are validating was taken from IE. And you can see here that the browsers render slightly different, and that is okay. It happens all the time, and it's a valid behavior. So the fonts have slightly different size, the position are slightly different, and you can see that the words are wrapping here differently in this paragraph. But of course the scroll bar is different. But then again, as far as layout is concerned, the images are consistent, except for this small missing element that we have in IE that the matching algorithm managed to find because it violates the layout. Okay, so you can see how layout matching can find very important bugs when doing cross-browser tests. The last example I want to show you is with the cross-device test. Okay, so in this case, we have a baseline in Samsung 4 with Twitter showing. And you can see that in one occurrence, we expect this paragraph to be aligned to the left and to the right of the image. And this is violated over here because these two lines of text shifted to the left, and therefore it's highlighted. And in this case, we have an image that is missing over here, and so it is also highlighted as a difference. So then again, cross-browser testing, cross-device testing, and highly dynamic application can all be tested automatically to find visual defects using layout matching. Any questions about what we've seen so far? Okay, so the last thing I want to show you is how we actually maintain and update the baselines. So right now in the test that we started with, you can see that I have a timeline at the bottom, and that the first validation point, the first tag here is green, meaning that no differences were found in that first step of that first validation point, and the rest three validation points are red, meaning that differences were found. This could be bugs or just changes to the application. What I also want you to notice is that its validation points captures a different state of the screen, but although the images are different, the changes are the same. It's the same three changes that we've seen in the second step, with Google logo moving, the typo, and the change of color here. And so if I want to approve this new screenshot, and let's say that these changes are valid changes to the application, all I need to do is to just click this accept button. But when I do that, the tool automatically analyzes all the remaining differences, and if there are any similar ones to the ones that I just approved, it automatically approves them for me as well. So in this case, you can see that with a single click, I already resolved all the differences in that specific test. And just to give an extreme example, if you have a website and you have like 1,000 validation points on it and you just change the header of the website, then it's sufficient to approve this change on only one of the occurrences, and the tool will automatically and safely approve all the other instances of the change. Of course, if there are other changes, it will not approve them, only if it's exactly the same change. And this is a very, very powerful way to allow you to automatically very easily maintain very large sets of baseline images. Another form of automated maintenance that we have has to do with those regions that I've shown you. So for example, if I want to place an ignore region on this element here, and I'm in the fourth step, and I move to the second one, then you can see that it was added here as well. And if I decide that it needs to be wider, and I move to the first step, then you can see that it's wide here as well. But on the third step, the element does not exist, and therefore the region was not added to this validation point to begin with. Okay, so that's about it for viewing test results and maintaining baselines. Unless you have any questions that you have at this point, I'll just go ahead and show you how you connect Applitools Eyes to a test automation framework and run a test.
Adam,
yeah.
This is Robert from Germany.
Yeah.
I have one question.
Yeah.
So on the Google example, I see, let's say, two different kinds of bugs. Like one is the typo, the Mora, and two are design bugs. Let's say the design differences are new features because the logo was moved and the button of the search button color was changed.
Yes.
So now I would like to accept these two changes as baseline, but the Mora as a bug. How do I do that?
Yeah, okay, that's an excellent question. So basically, the way that you do it with the product today is that you can choose between, the way that you do it is that you need to accept all of them today, and you open a bug in your bug tracking system that as long as it's open, you know that there's something wrong there, and your test will no longer fail for this specific bug, but you have a record for that bug being available. One of the features that are on our immediate roadmap, it should be available in about a month, is that we are going to add what we call a bug region. And a bug region is very similar to an ignore region, and you can just, let's say that this is the bug, you would mark it as a bug region. You'll be able to put some text here to denote that there is a bug here and it's not the way that it's supposed to be. And you can also decide how this region behaves. So you can say that you can accept the page, but the existence of this region will always fail the test. So as long as the bug region is not removed, the test will continue to fail, although you accepted everything here. The other thing you could do is you can tell the bug region to behave like an ignore region for a limited time. So you could say, okay, I want to ignore this difference for a week. So for a week, from that moment on, it will ignore the bug, but if it wasn't fixed after a week, it would fail the test again. Okay, so our customers today, this is a requirement that we got a lot. They are doing today, they are just approving it and having the bug marked in their bug tracking system. That's why they don't forget about it. But this is a feature that we are going to add very soon.
Okay, thank you very much.
You're welcome. Any other questions? Okay, so let's see how we can integrate it into a test automation platform. So basically the way that we've designed the product is that we decided not to implement yet another test automation tool. There are very good tools out there, and we decided to just allow you to hook Applitools Eyes into whatever thing that you like using and you're using anyway. And when you open up a free account, when you are a new user, you can always also get there like I did just now. You can get to the Getting Started tutorial. And here you have all the instructions you need to set up your first test. So for instance, I know that I want to work with Selenium. There are instructions for many other platforms. And I'd like to work with Java, just as an example. And I have here the instructions how to place a Maven dependency that would allow me to...
Followed by the pound or hash sign.
So the guy that just joined, if you can mute the mic, that would be great. Okay, so you have the Maven dependency here that you can place in your project configuration. It would just download the SDK for you, and you can just download the SDK directly, the DLLs, and import them manually. And once you've done that, specifically for Selenium and Java, in our case, you have an Eyes object that you can use to interact with the Eyes server. So let's see what this test does, and then let's see how Eyes integrates. So it's a very straightforward WebDriver test. I'll just go over it just in case there is someone in the audience that doesn't know what Selenium or WebDriver is. But basically, we create a WebDriver object here that we launch a local Firefox browser instance. Then we navigate the driver to this URL, and then we find the features button and we click it. So, and at the end we close the driver. So basically what we're doing is a very, very simple walkthrough using a Selenium WebDriver, where we just open up a web page and then click on a button and we get to another web page. So after I'm importing Eyes and the required namespaces, I have the Eyes class and I can create an object of it. I need to set the API key that was assigned to me when I signed up, okay, for an account. And then at the beginning of the test, I call Eyes Open. I provide a name for the application and a name for the test, and also the desired screen resolution that I want to test on. So this is important because it allows you to determine at what screen resolution you're interested of testing running your test, and also if your application is responsive, you can force the application into the required layout mode that you expected to test it on. After we got to the first page, we just have one line of code that says Eyes check window. Okay, and when you do that, a lot goes on in the background. So the tool goes to the WebDriver, gets a screenshot. If the WebDriver doesn't support a full page screenshot like Chrome, it only provides you a screenshot of the viewport, the SDK will automatically scroll and stitch the images available through the viewport and provide you with a full page screenshot to compare against. It will also wait until the page stabilizes, so you don't have to do any implicit or explicit waits in your code. Because it has a baseline, it knows how the application is expected to look like at that point, and it will just continue to check repeatedly until there is a match or until a certain timeout expires. There's a default, and you can also set that default for you by yourself, override it, But anyway, if the page stabilized after 1 second, then after 1 second you will move on in your script. But if it takes longer, then it will wait the necessary amount of time. Then after clicking the features button, then you do a check window again, which validates the second page, okay? And at the end, you call eyes closed, and if any differences were found, eyes closed will throw an exception that will fail your test, okay? And so if it's running in Jenkins with an unit or whatever, you will see a failure in Jenkins, and the exception subject will contain a URL to see the test results. So just see how easy it is to stroll through the application, insert validation points, one-liner validation points, where each one actually captures an entire screen with hundreds of elements and validates it for you, right? So this is how you integrate eyes and an automated, in this case Selenium, but it could be any other framework. And there is also the option to work with it manually.
Adam, a question?
Yeah, sure.
Yeah, on the earlier slide in the sample code.
Yeah, it's here.
So, yeah, in the sample code, so just to make it explicit, I guess we are saying that whatever regular assertions or validations you would have, that would continue to happen. We are just saying if we want to visually also inspect, we would say eyes.check window, right?
That is right. I mean, you can use eyes check window to do just to concentrate on the visual stuff. You can also, you don't have to check entire windows. You can also provide, just like you provide here to find element by CSS selector, you can provide smaller elements to validate. But as I explained in the beginning, if you have, and this is what we see the majority of customers do. So basically they start out by writing new tests that just do the validation stuff, or they're adding eyes check window to their existing test to do visual validation, but gradually they realize that in many cases they don't need the normal assertions there. They can just remove them because it's already covered by the visual validation part of it. So if you're doing something against the API or going to the database and checking this sort of stuff, then eyes check window won't cover it. But if you're trying to get a value out and make sure that it equals some string, then you've got it with visual validation. Unless, of course, it's a computed value that's different all the time and you have to ignore it in your test. So you would still need it. Yeah. So I hope that, okay.
So I guess the example would be that if I expect 10 emails to be there, and instead I've got some other number, the visual validation will say it was a different number than what I expected, but it would not tell me what was the different value itself.
Yeah, so when we're talking about cases with, like for that inbox, let me emphasize what you can and cannot do with it, so just to be more clear. So, okay. Of course, in this case, I mean, probably you thought about it when you saw this example. You're saying, yeah, but every time I run the test, I have different emails here, so what can I do with it? So there are several things you can do. So the first thing is that if I really want to make sure that the inbox, it looks good, and I need to make sure, like everything else, I can make sure that my system is testable in the sense that I can have a fixed database for emails that always provides me with the same emails. This way I have a consistent image that I can use Streak to verify, and whatever changes on that page, typos, style changes, font changes, anything at all, it will be captured by strict matching. If you cannot do that, if you don't have the time or it's impossible for you to mock the data, then there are several things you can do. First of all, you can test at the layout level, and then you can make sure actually that nothing got corrupted. So all of a sudden emails are not there, or the columns shifted, or I don't know, the Google logo appears in the middle of the page for some reason. And that's a very powerful way to do things with very dynamic data. The other thing you can do is actually use those floating regions, as I mentioned. So let's say that I would like to test that I'm sending myself an email and that the email arrived, right? So the way that I would do it is that I would write the test so it would send a specific email, and in this baseline, I will just highlight the specific email that I'm expecting as a floating region, and I would place the area in which it is allowed to move on the entire table. And now, as long as that email arrived and it appears here in this area, then I know that it has arrived. I know that it even looks the way it should look like with the yellow piece here, right? But if it's missing or somehow corrupted, then the test would fail. Okay, so you have a lot of options to do this type of testing. I hope it answers the question.
Yes.
Okay.
Yes, it does. Thank you.
You're welcome.
Adam, one follow-up from me, Robert again. Is it possible or maybe planned to have different validator options on one page? Meaning there's one area I'm validating strictly, one area I'm validating on layout 2 or something like that?
Yeah, so it is not possible to do it today directly the way that you suggested it. So it is on our roadmap to have like match regions that you can specify, not only to ignore, but you can specify the match levels that you want to have directly here on the baseline. The way that it is possible to do it today is just use check region instead of check window. And then when you get to a page, you can just check each region with a different match level. And so you would test the table in one and the Google logo in another. The way that it would appear is that you'll have multiple validation points, one just for the table, the next just for the logo, etc.
Okay.
By the way, something that is very nice as well that I didn't mention yet is about this timeline, that it allows you to play it back. So when I'm playing back the timeline, you can see that I can see all the different validation points, but also all the clicks and mouse movements that happened during the test. Now, this is not a video recording, a bloated video recording of what happened. This is actually a logical playback. In the case of Selenium, for instance, you can see here, let me get back there, that when I called eyes open, I passed in the WebDriver, and I'm returning another one, which is that you're supposed to use. And what we are doing is that we are hooking into that driver, and we can see everything that happened in Selenium, clicks, mouse movement, etc., and we send it to the server along with the images to validate. And the result is that you have, for every single test that you ran, a very nice playback that documents everything that happened in the test. It's much easier than reading logs or code, and everyone can understand it, but we never delete it because it's not a video. It doesn't take up space. Okay, so it's there forever. You can keep a link in your bug repository. Just put that link there, and everyone can look and see what happened in the test and whatever led to the bug. Just as a side note, I forgot to mention that.
Adam, this is Bharat from India. So I have a doubt. So as of you told, the images within a particular range, it will match. Like that, you can change the range of the particular image or content. So is it possible to verify that if sometimes the third O in the Google is in yellow color, in some other browser it might be in slightly orange color. So those kind of pixel acceptance range can be set.
Okay, so I understand the question. So this is the way that it works is as follows. So basically, when you are working with strict matching and you expect to find these differences, then you cannot use strict matching for cross-browser testing because, as you mentioned, as I showed you in the demo, the browsers render stuff differently. So strict would always pick up those differences, and you don't want to do that. So the way that Applitools handles it is that, as you can see, each test is associated with an environment signature. So in this case, it's Windows, it's Chrome, and this is the screen resolution. And you can run the same test again and again and again in different execution environments. Applitools will automatically determine the details of that environment, and it will keep a different baseline for each environment. You don't need to change anything in your code, but that would happen. So you will always have consistent baselines to compare with the screenshots that you are taking from any specific environment. Okay? Now, Strict was designed to we worked very hard on it to make sure that you don't need to configure any thresholds, because people are not image processing experts, and what happens is that when they start playing with these thresholds, they just open up opportunities for bugs to crop in. So if you're saying, I want 80% accuracy, basically you're leaving 20% for room for bugs. And when you're doing visual validation, you don't want to do that. So the answer is that Strict does not allow you to do any kind of thresholding. If you do want to work with exact pixel matching, then you can, through the SDK, pass in a lot of configuration options to determine and decide for yourself how you want it to be matched, starting from thresholds, from similarity metrics to limiting the size of different diffs, whether to consider them or not, and you have full control on that. But the recommended way to go is with Strict and have a baseline for each environment that you want your test to run on. That's by far the easiest way to build tests, to maintain them, and to have reliable results. Just to clarify, we have customers that are running tens of thousands of tests every week, okay, on our systems. Okay, so this is really large scale testing, visual testing going on.
Oh, okay. Yeah, thanks. That clears my doubt.
Okay, any more questions, guys? So,
hey Adam, this is Vardhan from India. I have a question.
Yeah.
Say you have a web application or mobile application which has a scrollable view. So does it take the image of whatever is there visible to human eye, or it takes a picture of the entire web page, even though it is a scrollable view?
Yeah, so I understand the question. So the good news is that it does take the screenshot of the entire page. And as you can see, for instance, in this example, you can see how big this web page is. Okay, and it managed to take a full page screenshot. Okay, and it does that not only for the main page, it does that for even if you have a frame in your application that has a scroll bar, and you can there is a method for the SDK that's called check frame, and you specify that frame, and the SDK will automatically change context from the page to the frame, scroll and stitch for you, and provide it with a full image of the entire frame, and then move the context back to the page. So in your test, you didn't have to do anything. It saved you writing tens of lines of Selenium code to do that, and you got the full screenshots of the frame itself. And it will do that even for browsers or platforms that don't support it. So for example, with LeanFT, I don't know if you've seen it yet, it's the new tool by HP, and similarly to UFT, it doesn't take full page screenshots if you ask it to. But with Applitools Eyes, you can get those full page screenshots out of the box for validation. So guys, we need to wrap it up. I just want to show you one last thing before I have to get on another call. We have an extension for Chrome that allows you to run visual tests directly from your browser, and this is very helpful for manual testers. You can choose the screen resolution, the match level, and there are also kinds of advanced options with the baseline. But basically, if I'm standing on a certain page and I want to validate it, then all I need to do is click this camera button, and it will automatically scroll and stitch that page for me. This is an example of what I just told you about. And when it's done, it automatically, okay, it will automatically show me the test results. In this case, we've passed. You can see that it's green. But if I'll go here and do some change, let's put in a typo. Let's say it's small business payroll. And I'll check it again. And then again, think of it as a spell checker for the manual tester. So, and even if think of localized pages that you don't understand the language, so it would be impossible for you to identify as a human tester a typo, or if some text is truncated, it's because you don't understand the language, right? But then again, if we look at the report, you can see that in this case, the test has failed and we have a difference. And if we zoom in, you can see the typo here. Right, and another thing about this tool that makes it very useful is that you can actually load the text file that has just like rows of instructions in it, and then you can follow, the manual tester can follow up with the instructions, and whenever he clicks the button, it moves to the next instruction, so it tells him what to do and when to validate. So it's a very nice tool that is also useful for manual testers. Okay, so if we don't have much time for any more questions, we'll have to wrap it up. But I hope that you got a good idea what Applitools can do, and that you found it useful for you.
No, thanks a lot, Adam. Since we are short on time, would it be okay if there are any follow-up questions, we just collate that and send it out to you, Moshe, and yourself?
Yes, of course. Yes, of course. And if anybody wants to try it out, you can open up a free account at our website, and just, it doesn't cost anything. You can just try it out for yourself and see how it works.
Excellent. Well, so everyone on the call, since we are out of time, I think we can just sync up internally and see whatever the follow-up questions we have. We can just collate that in a document and send it out, and maybe have a follow-up call if required, and if it makes sense in that way. Adam, thank you so much for this again, and we are looking forward to the link for the recording that we can share it with others as well. So thank you very much.
I'll send it to you later today. Thanks. Thank you, everyone.
Thanks, bye.